Randy Keir was going to MC this, but she got sick, so I'm going to try to fill in. Thanks everybody for coming. This is an awesome turnout. The Energy Committee is really excited to see everybody show up, and we're really excited about doing this. And I want to thank Matt Sargent from Efficiency Vermont and Paul Blanchard from FW Web for showing up and putting together this presentation, putting together their presentations for us. I'm not sure it came in. So with that, I'm going to get things going. And so I'm just going to flip through a couple slides here real quick to try to introduce what we're going to be looking at tonight. And of course, this is about heat pumps, of which there are two major kinds, categories. There's air-to-air, and there are ground source heat pumps. And what they do basically is pull heat out of the environment where we get free BTUs, and to pull them up out of the environment at the lower temperature, you have to spend a little energy. So basically what happens is the energy you spend to pull them up is, so for example, if you are pulling up out of this temperature well, for example, at say 40 degrees, you might pull up 2 BTUs in your BTU bucket, and it might cost you 1 BTU of electric energy to get it up there. And so basically what you're getting is a 3-for-1. 2 that you pulled up in the bucket, 1 that you spent. A 3-for-1 BTUs, and that's like a 3-for-1 sale at Walmart. That would be a COP of 3. So the first concept that I'd like people to be thinking about as these presentations take place is you get free BTUs and you have to spend very little to get it. Second characteristic that's important here is the deeper you go into the temperature well, the colder it is outside, the less efficient they are. They drop off. So for example, you might have at 20 degrees an efficiency COP of 2 because it costs more to pull those BTUs up out of the well and get it up to the top. So that's the second characteristic, is they don't do as well the colder it gets. So you probably want to be asking some questions as these come through about where the efficiency drops off and stuff. Lastly, all of these heat pumps really kind of stop functioning at a temperature very low, and the newer ones go pretty darn cold. But at some point, they do drop off to basically electric heat, so with a COP of 1. Okay, so with that, I'm going to go on to the next slide. There's a couple things, and I'm not going to spend much time on this. Just these are kind of some numbers that for Huntington, that if you had a COP of 2.8 and 1,000 against 1,000 gallons, you'd save about 20% or maybe even more. Going from oil to an air-to-air heat pump. And you could save even more if you went to ground source heat pumps. I'm not going to spend a lot of time on this because Matt has some numbers on this too. But you can see there's a significant savings in cost in the fuel cost or the energy cost once you had a system installed over oil and certainly propane. So let's go on to the next slide. Here's something that is near and dear to the Energy Committee as we get started on Energy Town Plan. This is with regard to Act 174 and as it pertains to our town plan. But this whole carbon footprint is really important to us. So again, with that 1,000 gallons throughout the season, you'd have like 12.8 ground source heat pump with this annual COP of about 3.3, you'd be down at 2.3 tons that you put out annually. One other point I'd like to make is over time, Green Mountain Power intends to go from their current, I think they advertise 0.4 pounds of CO2 per kilowatt hour. They're eventually going to go to, their plans are to go to 0.1. So this will drop to a quarter of that if they meet their goals. Okay, so that's, I think that covers the CO2 and what an incredible reduction you can have on your carbon footprint. Next slide. And then lastly, I just wanted to touch on what is going on in this building right now. As probably most know, we put in heat pumps in this building, and this is the first season that we're putting out that it's being heated with heat pumps. Oil cost was, at today's prices, if we still had the oil in the existing system, it would be $18,000, and the projected is, to be down around $5 or $6, or I'm sorry, $6, $7 or $8,000. And this isn't solely about the COP. There's also other efficiencies that went into the system that have to do with air exchange and stuff. But it's a significant savings in our fuel cost. More importantly, the emissions. We're down to about 10% of what the emissions used to be with oil. So where we would have put out 80 tons, we're now down to probably about 8 tons of CO2 per year. So very significant. I think we can all be proud of what we've done in our town and for this building. So that's the last slide I have, and that's the introduction I have. And at this point, I'd like to turn it over to Matt at Efficiency Vermont, and let him. First, we got to hook up his computer and such. But so anyway, I think at the moment, I'm not sure if Matt wants questions along the way. We can certainly ask and have questions answered at the end of the presentations.
Is CO2 cost of production? I'm sorry, what's the COP cost of production? What is COP?
COP is the
Repeat the question.
coefficient of performance, and it's to calibrate yourself. A COP of 3, if you want to get to cost efficiency, like what is in your boiler, which is like 90%. So to put that on that scale, a COP of 3 would be a cost efficiency of like 300%.
Okay, we're going to get going with this part of the show. Thanks everybody for coming. It's so great to look out and see a bunch of people who want to show up and talk about heat pumps.
Matt, you want this off or on?
On a random Wednesday night. It's awesome.
Matt, you want lights on or off?
Lights off, I think, is better for view of the presentation, and it takes some of the focus to the screen and off of me, which is awesome. I'm here as a representative of Efficiency Vermont tonight, and I'm not really here to sell heat pumps. I'm here to provide you guys information, and it's my goal that at the end of the night, people in the room walk away with some background knowledge of what is a heat pump, what are some pros and cons, and maybe you'll have enough information to decide if you think it makes sense for you to move forward with looking into installing one in your home. So I'm not here to promote any particular brand of heat pump or any particular installer or distributor. I'm just here to provide information, just to give you the skinny on, what is this thing and how they work. So that being said, we are Efficiency Vermont. We are the statewide energy efficiency utility. We're the first one in the nation. So in 2000, the Department of Public Service decided that they wanted to have one entity manage energy efficiency programs for all of the electric utilities in the state. There are like something like 20 electric utilities if you count the small municipal ones and stuff. So prior to that, each utility ran its own energy efficiency program, and you got pretty widely varied services depending on who your electric company was. So they wanted to make more level playing field, so they went to the Efficiency Vermont model, and we provide services all across the state for all Vermonters. We provide energy solutions through education services and rebates. And we have a statewide network of contractors called our Efficiency Excellence Network. And I guess, lowdown on that is that we have been going around recommending doing all this really specialized kind of energy efficiency work for a long time. And for a while, there was nobody around to do it. So we work with contractors in the state, and we now have a pool of contractors who are well-versed and well-trained in some of these things like installing heat pumps. So if you need to find a contractor, you can go on our website and search one up. Anyways, that's it for the spiel on what Efficiency Vermont is. What we're going to get going on today is we're going to look at an introduction. What are they? How do we do heating with them? What the savings look like? What makes a good installation? And how Efficiency Vermont can help. And we do provide some rebates and some information and stuff like that. So, what's up with heat pumps? They're efficient, and they do heating and cooling. And it's a relatively painless procedure to install one. We don't have to do a lot of renovation work. It's simply run a line set, a refrigerant line set, and run a big power cord, and bolt the thing to the wall, mostly. We do have to drill a hole through the wall to get the line sets from outside to inside, but it's a pretty easy install. If you happen to have a renewable energy system, now you're talking, because you can make your own energy to heat and cool your house with, which until now has been pretty hard to do. So, what is it? I like to tell people that it's an air conditioner that works backwards. So, imagine you're walking down the sidewalk and you're going by an old storefront and they have a window air conditioner, right? And it's a hot summer day, and as you walk by the air conditioner, you can feel that it's blowing hot air on you, right? So what it's doing is it's moving heat from inside the store to outside. Now, this is, if you were to run that air conditioner backwards in the wintertime, you would be moving heat from the outside air and putting it inside the building. Okay? And they do this with a refrigerant cycle. Now, I'm going to give you a little primer on refrigerant cycle, but I promise not to get too technical. If there's any technical people here, you can throw wads of paper and stuff at me if I get it wrong. But I'm going to give it a crack. So, we start out with a heat source and a heat sink. Now, in this case, if we're using an air-sourced heat pump, the heat source is the outdoor air. So we're taking the heat that's in the air outdoors, and we're moving it to the heat sink, which is, in this case, the air that's indoors. Right? So what happens is we do this with a refrigerant, and the refrigerant gets really hot when we compress it. We run it through the compressor. And it goes inside this hot refrigerant, goes across the coil, and we have a fan that blows air across the coil and extracts some of the heat off the refrigerant. Then the refrigerant comes through here and it goes through this expansion valve and it turns back into a gas, in which case it gets very, very, very cold. Okay, so it's going to be colder than the outdoor air. And we're going to, again, put it across the coil, blow a fan through it, and we're going to extract some of the heat from the outdoor air, bring it over to the compressor, compress it again, and make it hot again, and then bring it back in. So the energy that we're providing into this system is just to run that compressor. Right? That's what we're doing. We're running a compressor, we're compressing a refrigerant. There's no combustion. We don't burn anything. There's no electric resistance coils in it. Well, not in the ones that we're going to talk about tonight. And that's the heat pump cycle, right? So that's basically what we're doing. We're compressing refrigerant and we're expanding refrigerant. And we do that, it gets hot and it gets cold. We use that to our advantage. So let's talk about heat sources. There's a couple of terms I'm going to give, and heat source is one of them. You've heard the term air source heat pump, maybe, or ground source heat pump, right? So the source is like where we get the heat from. And in this case, on a ground source heat pump, it's coming from the ground. So our refrigerant cycle now is we have the refrigerant and we pump it through all this tubing in the ground, and it picks up a little bit of heat from the ground. We run it through our heat pump, we extract some heat and dump it into the house, and then it's cooled off, and we come back here, we heat it up again with the ground. Okay? How cold is it in the ground? Do you know? Roughly 45, 50 degrees, somewhere in there. Depends how far down you go. Right? These trenches usually are about 6 to 8 feet deep. They have poly tubing, similar to the tubing that carries water from your well to your house. And we got a lot of tubing coiled up in that trench to get a good heat exchange. Typically, there are 8 or 10 trenches like this to run the ground source heat pump for a house. So they get pretty spendy. Here's what they look like, except in real life they're not floating above a weird field. They're typically installed in the basement. But the line, the refrigerant comes in and out of them, or the water comes in and out of them. They got some gauges on them, stuff like that. It's a box, goes in your basement. It's got a compressor in it. So that's how we extract heat out of the ground with a ground source heat pump. You can imagine all the excavation work makes it pretty expensive to install, and you'd be right. So here's a water source heat pump. We're doing the same kind of thing with the water in the aquifer. We're using the water, the heat that's in the water in the aquifer, and we're bringing it up, and we're extracting some of the heat out of it with a heat pump, and we're putting it back in the aquifer. It's pretty common to see these in a drilled well, or what we call a vertical column. And this way, we're pulling water out of the well, we're extracting some of the heat out of that water, and we're putting the water back in the well. If we keep doing that, we're going to cool the water off in the well to where it's so cold, we can't really do it anymore. So we need a lot of well. We need sometimes 3 or 4 of these wells, or very deep wells, 800 or 1,000 feet deep. So that's typically how that's done. And again, that can get pretty expensive too. All that well drilling costs money. But with an air source heat pump, we buy an air conditioner and we stick it outside. Right? So it's a pretty simple installation as opposed to the other two I just showed you. This air source heat pump, it's up on a stand. Got to get it up out of the snow because it doesn't work so good if it's buried in snow. Here's the refrigerant line set. It's insulated with this black insulation, so that's what that looks like when it's going into the house there. And this is the electric line that runs power out to it. You do see it. It's outside, and it has to be in the open because it has to be exposed to the air. You can imagine we're trying to extract the heat out of the outdoor air in the winter in Vermont. So it's a reasonably scarce source. But the good news is there's a lot of air out there. So this thing needs to be open to all that air. So if we put a shroud around it or put it in a little, Snoopy house or something, it's not going to work. Here's another schematic. And this just basically illustrates what I showed you already. Here's another schematic which basically illustrates what I showed you already. But this one's cool because it shows an actual house kind of scenario. Here's the outdoor unit. Here's the line set. And then here's the indoor unit up high on the wall. Most of these wall units take air from the top. And they condition it and they blow it out the bottom. These fins out the bottom, you can direct the air in any direction you want it to go. They're pretty sophisticated machines. Some of them have a little infrared sensor on it. It senses like where's the people in the room, and it directs the fins away from the people so you don't have cold air blowing on you or warm air blowing on you. It makes you uncomfortable if air is blowing on you at a certain point. So in this case, the heat sink is going to be the air in the home. The heat source is the air outside. The heat sink is the air inside. Here's another heat sink type. wanted distribution, you had to go to a fairly elaborate ground source heat pump, or to go with a ducted air source heat pump, which many times are not so good in cold climates. This will work good in cold climates, and I think people like radiant heat, so for maybe new construction, it might be worth looking at. We were really hoping that they would come out with this technology and be able to make hot water so that we could run it in baseboard heat or radiators or something like that, which would allow us to retrofit a lot of the existing boilers that are out there. Unfortunately, this stuff, produces heat at about 120 degrees. So great for radiant floors and domestic hot water, not so great for baseboard hot water. So we're still waiting on the super hot stuff for baseboard hot water, but this is great new groundbreaking technology. So another thing we can do with heat pumps and a different kind of heat source is domestic hot water. So anyone heard of a heat pump water heater? Okay, a couple folks. So it looks just like an electric water heater. In fact, it is an electric water heater. The red thing on the top is a heat pump. So the heat pump is taking the heat that's in the air in that basement and it's putting it into the hot water in that tank. And off the back side of that heat pump is blowing cool, dehumidified air. So in some basements that have dehumidifiers running, these things can do some of that dehumidification load. But how much is going to depend entirely on how much hot water you use, because it's not there to be a dehumidifier, it's there to be a water heater. Space is a consideration here. So this thing uses the air that's in the room. So if you put it in a very small room without much air, right, it's going to cool the air in that room down quite a bit, and therefore it's going to be less efficient, and at some point maybe it won't work so good. Drainage, so they do, like I said, they dehumidify the air, and that means we need to have a little condensate drain or a pump. So that's a consideration. Also, and Efficiency Vermont's offering a $400 discount on those. So if you want to know more about that, come see me later. We came to talk about heat pumps. In this case, I think what we're meaning is space heating with air source heat pumps. So if we're going to talk about heating with this technology, I want to get into some terminology that you hear thrown around quite a bit. So a heat pump is like this overarching terminology. So when someone says heat pump, they could be talking about a refrigerator that's got a refrigerant compressor and a cycle in it. You could be talking about an air conditioner. They could be talking about an air source heat pump or a ground source heat pump or anything. It's all heat pump. A ductless heat pump is simply a heat pump that doesn't have ducts tied into it. A mini split heat pump is a heat pump that has an outdoor unit and an indoor unit. Right? There's two parts to it. Like that schematic that I showed you with the outdoor thing and the indoor thing on the wall, that would be a mini split. And a multi-split is the same thing, only the outdoor unit can power like 2 or 3 indoor units. Right? So that's some terminology. I want you guys to see everybody clear with that. It's pretty easy to follow. Here's some other stuff. So when we talk about how efficient these things are, right, we use these terms to put comparison between one unit and another. It's really hard to compare like the HSPF, which is the heating season performance factor of the heat pump, with a wood stove, right? So I'm going to walk you through what we're doing here. So the HSPF is doing this. It's saying how efficient is this thing over the course of a whole heating season. So during the cold days, it's going to be less efficient because it's working harder to extract heat out of that cold air. And on the warmer days, it's going to be more efficient. So over the course of the whole season, it was really efficient on this day and not so efficient on that day. How did it do? Average. So that's your HSPF. And the SEER, the seasonal energy efficiency ratio, is basically the same thing for cooling. How efficient is it at cooling over the course of a whole season? It's got its ups and downs. On a really hot, humid day, it has to work harder to be cooling. So, and the strictly this. How efficient is it at cooling when it's working really hard on a really hot, really humid day? Like 95 degrees out, 100% relative humidity. This thing is trying to do cooling in a building. How efficient is it at doing that? COP. Okay, we talked about COP earlier, coefficient of performance. Now this one gives us a way to compare the efficiency of a heat pump to the efficiency of a traditional heating system like a boiler or a furnace. Right? So when we say it's got a COP of 2 to 4, that means it's got equivalent to 200 to 400% efficient. So I know that sounds crazy, right? How can something be 400% efficient? Well, we tried to describe it earlier. The COP is the energy out divided by the energy in. So how much energy can the thing produce, and how much energy do you have to put into it to make it produce that amount of energy? Right? And remember, we're not generating heat. We're not burning anything. There's no electric resistance. We're moving heat with that refrigerant cycle. So let's look at that. How do we get more out of it than we put into it? Well, we start with our heat pump. And then we start with a heat source. In this case, we're going to talk about the outdoor air, right? And we put some energy into it. So let's say, for example, whether it be kilowatt hours, we put 1 kilowatt hour of electricity into this machine. With that 1 kilowatt hour of energy, it does its magic cycle there, and it can move 3 kilowatt hours of energy from outdoor to indoor. Right? So we're moving 3 units of heat by providing 1 unit into the heat pump. And that gives us a 3 to 1 ratio, or a COP of 3.0. That's how you get 300% efficient, honestly. It's not that difficult to understand when you look at it like that. How do they work in the cold? Well, they do work. We recently had a little spat of cold weather around the beginning of the year. We have monitoring systems on a lot of buildings that use heat pumps. What we were able to see is that they do operate. So for example, we have several homes that are clustered in Hardwick. It got very cold there. In minus 22 degrees, we saw some heat pumps would kick off at their low temperature limit. And some heat pumps, same kind of house right next door, kept working. Mitsubishi says these heat pumps, that's the manufacturer, says these heat pumps have a shut-off at minus 18. Well, apparently some of them do, some of them don't. Interesting. I have a couple of Fujitsu heat pumps in my house. And I'm not saying one brand's better than the other. I got them because they were cheaper, right? And they haven't shut down yet. But they do lose efficiency. So as it gets cold, they work hard. And they have reduced capacity. That means they can produce less heat. And they have reduced efficiency. That means that they're less efficient at producing less heat. So at some point, it's going to make sense to switch back over to whatever your main heating system is. So we're not advocating that if you put a heat pump in your house, it's going to be able to handle the whole load of your house all the time. Right? So we're talking about displacing or offsetting some of the energy that you use to heat your home with a technology like this. Well, how much? So that's what a Douglas space split looks like, except this thing's bigger than that, and it goes outside, and then this thing is smaller than that, and it goes inside. They got it kind of backwards. There's a great display over here. You can see what some of them, those are Daikin's look like. So let's talk about this displacement model thing. So if you have a home and it's got a heating system, it's making that heating system in your home now is providing 100% of the energy that you use to heat your house, right? And that could be a hot air furnace or a boiler. It could be a combination of the two. It could be, a wood stove and a space heater and a furnace, or whatever. We're going to call that your central heating system. And it's doing 100% of the work now. And we're going to add a heat pump, or maybe 2, and we're going to expect that we can displace 80% of the work that the central heating system does. So in this case, we've broken it down to dollars per million BTU. And you can see that natural gas and wood, cordwood, are pretty cheap. Pellets start getting more expensive than fuel oil, propane, kerosene, all these guys. And an electric resistance is way out here, like $44 per million BTU. Now, the heat pump from the electricity used in a heat pump is around $17 or $18 per million BTU. Now, let me talk to you about millions BTUs. Not everyone talks about million BTUs, so maybe you didn't hear this before. But each of the fuel types that are up here on the wall come in a unit, and there's so many BTUs in that unit of fuel. But how do we compare? How do we compare, a gallon of propane to a ton of wood pellets? Right? It's gallons and tons. It's apples and oranges. It's hard to. But each of those units has so many BTUs available in it, and we burn them at different efficiencies, right? And the units have different costs, so we can break it down. We can say this thing costs so many dollars per million BTU. And so when you look at it that way, this gives you a way to compare, like, what fuel costs. How do they relate to each other? So, who uses propane? Okay, fair enough. People. Who uses fuel oil? Okay, about the other half of people. How about cordwood? Everybody, cordwood. Well, so everyone uses either propane or oil and some cordwood, except for a couple people who doesn't raise your hand when the audience is pulled. So this gives us a way to sort of compare. And it also gives us a way to look at the savings. The electricity from a heat pump is somewhere in between the cost of wood pellets and cordwood. And your mileage is gonna vary a little bit depending on what you pay for fuel. These were like 5-year averages, and we're starting to creep back towards those costs, but maybe we're not quite there. But fuel costs have been cheap recently. So maybe it doesn't cost quite that much at your house, or maybe it costs more, but it's gonna depend on what the efficiency you burn the fuel is and how much you pay for it. So a typical residential home is going to use about 75 million BTUs a year to heat the house. That's sort of the missing link, like how much energy is in a million BTUs? About 75 million BTUs per year. So if we're burning 75 million BTUs per year and we're heating with oil, we're going to use about 600 gallons, and we pay that much for it. It's going to cost us about that much. So your average 2,000 square foot home in Vermont, heating with an oil-fired furnace, probably going to cost you a couple $1,000 a year to heat the house. Again, this is like average walking around numbers. So what do our savings look like? If we displace 80% of the main heating system with a heat pump, this is what our savings look like, right? So if we had electric resistance heat, we'd be saving, almost $1,600 a year. Not bad. Well, that's theoretical savings. So let's look at this. This is a case study of a home in Burlington, Vermont. Right? It's a 2-story, 3-bedroom house, and a little over 2,000 square feet. They did a little bit of weatherization work in the attic, and they put in 2 heat pumps. They were using about 584 gallons of fuel per year. And what were we saying? This house was looking at around 600 gallons a year. So this is a pretty normal house based on what I just gave you was the average. Here's the main split stand installed. They got one that's like in between the kitchen and the dining room. They got another one over there in the bedroom. That's what the indoor units look like up on the wall. So how do we do? So before we used 584 gallons of fuel, and it cost us a little less than $2,200 a year. After, we used 188 gallons of fuel oil, but we used some electricity to run the heat pumps, right? When we add it all up, it cost us a little over $1,500. So we saved about $600 per year. That's pretty good. But we also saved 3,000 pounds of CO2. Because we're operating at a much higher efficiency, we're able to use a lot less CO2. So that's a real world story. What do they cost? go out on a limb here and say the average cost for a single zone air source mini split is about $4,000. You can get them for less, you can get them for more. Some of the things that will make it cost more is if you have a full breaker panel. There's no room to add another 240 volt circuit to run that heat pump with. And you have to have a sub panel installed. So you're upgrading your electric service adds to the cost. Also, tricky configuration of the house adds to the cost. If it's a really simple installation, also the different brands of heat pump, different styles, different sizes, they all have different costs associated with it. A multi-zone, you can expect to pay over $6,000 for one of those. Remember, the multi-zone is like one outdoor unit and 2 or 3 indoor units. So maybe 2 indoor units and 1 outdoor unit might be around $6,000. Depends again on your house. Ground source heat pumps at $20,000. I've never seen one installed that cheap. So that is like the way super bottom end of the barrel. I'm not sure you can actually really do that. So when should you do this, right? If your home is air sealed and insulated, it's going to be much better at being heated by a heat pump than if it's not. If your house is leaky and poorly insulated, that heat pump is going to work a lot harder, and you're not going to be as comfortable, and savings won't be as great. So start there. If you haven't, try to get an energy audit done, or talk to somebody who's knowledgeable about these things and see what you can do. I can't stress that enough. Like, start there. Efficiency first. Do that first. If your home has an open floor plan, like a lot of modern homes, people are into these big open spaces, and they heat well with heat pumps because that heat pump up on the wall can see the whole room. Now, if your home's chopped up into little rooms, it's going to be a lot harder to heat it with a one-point source heating system like that. It's like having a little space heater. So the little space heater way down the other end of the house isn't heating you over here. Same kind of story. So if it's an open floor plan, that works well. Multi-story building, I think what they're trying to get at there is that heat travels vertically pretty nicely because it uses convection, warming it rises. You have to use some kind of delivery system to make it go sideways. So think about that. Again, we're not advocating that you get rid of the heating system in the house because you're going to need that on cold days. You're going to need that to heat that back wing. Multi-zonal heating is nice. Like, say, for example, if you have a boiler and the house is on a couple of different zones and you want to put a heat pump in the zone, in this zone and not in that zone, then you can still run the other zone with your boiler. If you have a higher furnace and the whole house is on one zone and the thermostat's in the same room with the heat pump and the heat pump satisfies the furnace thermostat, then you may be cold in other parts of the house. So you might want to consider moving the thermostat or be careful where you put the indoor unit head on the heat pump so you don't run into that problem. Sometimes it's hard to overcome, sometimes it's pretty simple, but it's going to, again, depend on your house. And again, if you have renewables, you can make your own power for doing your heating and cooling. So what's a good installation look like? We talked about the proper placement of both the indoor and the outdoor unit. So the outdoor unit needs to be up out of the snow. Don't put it under the gable end of your home, don't put it under the drip line of the roof, under the eaves, where it's going to be ice damaged and have a steady drip on it. If you do that, we recommend you get a little shelter roof over the top of it. I'll show you a picture of one of those a little bit later. The refrigerant line set. So I see this done wrong sometimes, where they don't get the insulation on that line set all the way back to the outdoor unit. And what happens then is you've got your hot refrigerant running through a bare copper line for 3 or 4 or 6 or 8 or a foot. So that matters because that's where the fluid is its hottest and that's where it's coldest outside. So it's robbing all the heat before you can bring it inside. Also, the refrigerant line set penetrations into the building was called out to a job where the mice, they put the lines in, they put a big hole in the wall, and they put the line sets in, and they used spray foam insulation to seal it all up really tight. And then the next year they went to start it and they found a huge mouse nest in the indoor unit. And what had happened was the mice had chewed through the foam and gone inside and climbed up the refrigerant lines and into the indoor unit and made a little nest in there. So yeah, that was kind of a disaster. So there's ways to do that. We don't have that problem. The closer we can put that outdoor unit and indoor unit, the more efficient the system is going to be. And I think there are limits on the line sets. I'm going to let Paul talk about that later. And again, integration with that existing heating system. So figure out how you're going to control the heat pump, how you're going to control the boiler. I think it makes a lot of sense if you've decided that the electricity with the heat pump is cheaper than the fuel that you're paying for now. You want to run your heat pump more than you want to run the more expensive fuel, right? Because it just makes good financial sense. So you want to set the boiler or the furnace down a few degrees. We've talked to people on the phone who've called up and they're really unhappy with their savings. They're just not seeing the savings. In fact, it's more expensive than it was before. Well, they didn't ever turn down their heating system. So they're running both simultaneously and they don't really know how much work either one is doing. They're not getting any savings there. And I see people going, well, duh, but really, don't forget. So, some other things, they make a little bit of noise, right? That outdoor unit is a compressor. It's sort of like having a window air conditioner running. Makes a similar kind of noise and sound, but it can also produce a little vibration. So that outdoor unit, it's pretty popular to hang them on wall brackets on the outside wall. And depending on what kind of wall it is, if it's a thinner wall, like a 2x4 wall, a lot of that vibration from the compressor transmits through the wall, and the inside wall becomes like a sounding board. And I've seen several installations where it's actually louder on the inside of the home than it is on the outside of the home because of that reason. So ground stands are a good way to combat that. It's a little metal stand that goes under. I think we saw one in an earlier picture. But you get them up out of the snow, get them out of the drip line, you put them on a ground stand. Or, the wall brackets are fine if it's on a wall that no one's trying to sleep on the other side of the wall. Like if it's a garage wall or something like that, that would be fine. But they do make a little bit of noise, and you are going to see it, right? It has to be out in the open. So get used to that. That's one of the downsides for many people is they don't like the aesthetic look of it. But don't go to any great lengths trying to hide it in an enclosure or it won't work so well. And another thing we talked about, it loses capacity and efficiency at colder temperatures. So minus 15, many of these are rated to minus 13 or minus 15 degrees, and they will produce 75% of their rated capacity at minus 15 degrees, and that's pretty cool. But the efficiency is really not there when you're doing that, right? It's working really hard to do that. But it still works, and it's still a better deal than electric resistance, even on those cold temperatures. Again, we talk about the thermostats, so making sure that you know how to operate the thermostats, and that one's not satisfying the thermostat for the other in a manner that's going to make you uncomfortable. So, what is the best way to operate this? We've seen, let me tell you a little story. We built these two passive house homes in Charlotte. They were Habitat for Humanity houses, right? So they're very similar, and they each have a family living in them. They each are being operated by one heat pump. That's the only heat in the house. And in one, a family of refugees from Africa moves in, and it's their first winter in Vermont, and they cranked their heat. They were cold. They were like, no, we want, so they turned up to 85 degrees. And I would have done the same thing. And on the other, a thrifty family of four, Vermonters lived in the other home, and they set the heat back all the time. They kept the heat really low, like 64 degrees, and then they set it back to 55 degrees at night, and then they turned it up for an hour when they woke up in the morning, then they turned it off when they went to work, and then turned it back on when they came home. They were doing all this stuff. And what we found was at the end of the year, the house where it was set at 85 degrees and just left really used no more energy than the other house. Because the other heat pump, now imagine this, if you set your heat back at night with a heat pump, and then you turn it on in the morning, and you're asking it to raise the temperature inside the home 10 degrees, when it's minus 10 degrees outside, it's working really hard at its worst efficiency, and it's doing the lion's share of the work. It could, with the capacity that it has in those cold temperatures, it could probably maintain the temperature of the house, especially a well-built, good envelope, right? But it's a lot of work to raise up the temperature. And it was working at such a poor efficiency doing that they really didn't gain anything by doing that. Now, that's hard for me to say because I have made my living for the past 25 years telling people to set their thermostat back at night. And that's still the case if you have a boiler or a furnace or some more traditional type of heating system, right? But not with a heat pump. So set it and forget it. And I talked about maximizing use of the heat pump before. If it's going to cost you less to run the heat pump than the boiler, run the heat pump as much as you can, and run the boiler as little as you can, right? Because that's going to make good financial sense. Get it serviced. Now, I keep asking every time there's a heat pump installer. I always say, like, what do you recommend for service? And most of them say, keep it clean. Just keep the filters clean. Keep the coil, the outdoor coil clean. Don't let a lot of leaves and junk get in it. Keep the indoor filters clean. The indoor unit has a really easy filter to access. You should be doing that pretty regularly. And that's what they recommend for service. And I think it would be good to ask whoever installs it to go by and take a look at it every year or two, make sure that it's okay. Come up with some kind of service plan for it, some maintenance program for it, and it should last quite a while. I think most of them are looking at like 12-year warranties, so it's a pretty good investment for 12, 15 years. Here's a little roof that they built over an outdoor unit. This is on a home in Shelburne, a new home. This is on the wall brackets that I was telling you about, and this is on a garage wall, so they weren't really concerned about that vibration in the wall. And here are a couple different styles of indoor units. This is a floor mount unit, and I think we have one of these in the display over here. And this is a flush ceiling mount unit. So if you want to get a little bit fancier, you can. So if all this so far seems like a pretty good deal, and you're ready to look into it a little more, here's some things you can do, right? So you can contact Efficiency Vermont, and we can hook you up with a network of contractors. Then you get a couple quotes and you hire one. I always recommend get a couple quotes when you do anything in your house. Or you're hiring somebody to do something, and you get one quote, you really don't know what that means. Is this a good deal or not? Maybe you can ask around, but if you ask another person to do the same job, and you find that they can do it for a lot more or a lot less, it gives you a sense of where you're at. Then you get it done. So I pick out a contractor. This is our Efficiency Excellence Network. We have a pool of qualified contractors who can install heat pumps, and these guys all qualify for the rebates. We have a Find a Contractor tool on our website. You put in your zip code and you tell them what kind of contractor you're looking for. It gives you a bunch of names. Okay, remember when we talked about the HSPF and the EER and the SEER? Well, here's where it comes into play. So at Efficiency Vermont, when heat pumps were first coming around, we wanted to make sure that if we were going to get behind this, we needed to be sure that these were good heat pumps to use in a cold climate. So we came up with a metric for a cold climate heat pump that will work and produce heat for people in Vermont. Now, a lot of these were pretty common in the mid-Atlantic states, and they weren't really that good at heating because they weren't able to function at cold temperatures very well. Well, they changed a lot of that. Now they operate at very high refrigerant pressures, and we can get them to work at very, So for a single zone, we're saying the heating season performance factor needs to be greater than 10.3, the EER above 12, and the SEER above 20. So I think the ones that they're coming out with now, the cold climate heat pumps now, a lot of them have SEER ratings that are around almost up to 30. They're like 28, 29 SEER. Does anybody know what an Energy Star air conditioner, what the SEER is on an Energy Star air conditioner? It has to be higher than 14. So a good Energy Star air conditioner is 14, and this thing is 29. So very, very good at cooling. For heating, I mean, the HSPF, our minimum HSPF for single zone is 10.3, but they're up around 14 now. So these parameters were set a couple years ago, and that's how much better the equipment is all of a sudden. For multi-zones, there's a little bit different. The SEER rating drops a little bit on the multi-zone. And we said it has to be good at working in cold weather. So we want a COP, coefficient of performance, at 5 degrees, better than 1.75 at maximum output, right? So if it can do all that, and if it can operate below 5 degrees Fahrenheit, we will give a rebate on it, and we will say this is on our eligible qualified products list. All of these manufacturers make stuff that meets this criteria. So I'm not here to represent any particular brand, but those brands all make the cut. Not all of their units. So they make a unit or 2 or 3 or whatever, but not all of their units will make it. So you do have to still make sure. Just because it's one of those brands doesn't mean it's automatically eligible. And here's what our rebates look like. So $600 or $800 depending on single or multi-zone, and that's at the distributor. So you don't have to fill out a rebate form. Your contractor doesn't have to wait for a check back in the mail. It's a wholesale discount. Makes it easier. There's some financing options, right? So if you were to finance one, it might make it a little easier than coming up with $4,000 or more. And depending if you're a homeowner, or business, or a farmer, you can get different types of loans. So here's a loan type. I don't know if anyone's seen this one yet, but the Heat Saver loan depends. The rates go up and down depending on your income and the longevity of the term. So, for example, if you were to, remember we talked about insulating and air sealing, and how important that is. Here's a product where you can borrow up to $35,000 for up to 15 years at pretty good rates, and it's not a home equity. No one's going to come and take your heat pump back. No one's going to seize your home. So it's done through VSCCU or Opportunities Credit Union. And if your income is in this range, here's your interest rates. If your income's in this range, you have a separate set of interest rates and so forth. But here's the thing. If you were able to take, like let's say it's going to make sense for you to do a little bit of insulating and air sealing and put a heat pump in, and that's going to cost you a certain amount of money. And if you were able to take that money in a loan and you were able to push the term out far enough that your savings, your monthly savings exceeded your loan payment, then it would be a positive cash flow. And then, your savings are paying for the measure. If you could only take out the loan for 2 or 3 years, you might not be able to get that. Right? So you'd be making the loan payment, you'd still have a negative cash flow. So if you can get to positive cash flow, it sort of becomes the cost of not acting, right? So you could do something and your monthly cash flow would improve. Every day you don't do it costs you money, right? So think about it that way. I know it's really hard to pull a trigger on a big, expensive item like this, but sometimes it makes sense. And really consider it because you can tie this into some weatherization work and get more comfortable and pay less money. And that's what we're trying to help you do. If this makes sense for you. If you heat with cordwood, does this make sense? Not financially, but it might make sense that you don't want to handle Or it might make sense that you have to, go away for some period of time in the winter to take care of a sick relative or go on an awesome vacation or whatever. And you don't want to have somebody, having to stay home to feed the wisdom. It might make sense then, but it wouldn't make financial sense, right? It wouldn't be like a slam dunk, like, yeah, it's so much cheaper than cordwood. Not really. Or natural gas. I mean, if you have natural gas, the numbers don't really work out that well. So be careful. The more expensive fuels you're going to see, the better savings. There's more opportunity for savings there. And I think we got through the whole thing without a single question. And I should probably have started at the beginning by saying, it's totally fine to ask questions during this. But that's what I got for you. So does anybody have any questions? Can we turn the light on?
Just going to go over and do that.
Yeah. Thank you very much. Yeah, sure.
Do they have heat pump systems that instead of running it where you're heating heating the water and then heating air to get out, do you have any that actually tie into your radiation heating? Is that a thing?
So is there a heat pump that ties into the hydronic heating system in your house?
Yeah. So you've got you've got oil, or sorry, at my house we have oil heating that runs into radiators, right? So the question is, do they have heat pumps that just tie that in with the water?
Yeah, I talked about that air to water heat pump earlier, and I showed the example of the radiant floor.
That's where they haven't got the efficiency.
They haven't got the heat high enough. The efficiency's there. It's just as good as these, but it doesn't get the water hot enough to actually operate a baseboard or radiator system. You could swap out your radiators for radiant panels or something like that, but then that costs and costs and costs. So not yet. We're hoping for that. Any question in the back?
So along these lines for the radiant flooring, you said that's a new kind of state-of-the-art way to use the heat pump and heat under your floor. What's that again? Is there a heat pump on the outside of your house and then you need a pump to pump the water or under your floor?
Yeah, you would need another pump to do the distribution. If you hook this thing into a distribution system, like a radiant floor or even a hot air furnace, you're going to have some more energy use in the distribution. Right now, with a packaged unit, like a mini split like this thing over here, all the energy is accounted for. Like the energy from the fan in that indoor unit is already accounted for in that CLP. But when you start tying things into, external distribution systems, then you've got more energy that's not in the equation.
So what was the new excitement you were talking about?
That's called an air-to-water heat pump. Remember we talked about heat source and heat sink? So this thing is commonly referred to as an air-to-air heat pump, and the other one would be an air-to-water heat pump.
It's the same, so the air-to-water heat pump is the water that you then send into your floorboards?
Yeah, so it uses this refrigerant technology to heat water as opposed to heating air.
And you can get it hot enough to heat your floor, but not your domestic hot water.
No, that's the only that's the only downfall. You're married to the physics of air conditioning. You're married to the physics of what it is. The warmest you're ever going to get is about 120 degrees. If you have a staple-up application, that 9 times out of 10, when it's really cold out, that water's not warm enough to heat the space. If you have a gypcrete or a concrete foundation, that's a lot different. Then you could utilize what Steve is talking about to do your space.
So Paul's talking about underfloor staple up radiant heating system, which sometimes, depending on how many layers of flooring are above it and whatnot, is going to need to be warmer than 120 degrees. The heat in that water, the temperature of that water will need to be more than 120 degrees. If you have embedded tubing in a concrete slab or in a thin slab on top of the subfloor, then those can operate with lower water temperatures, which might be done with an air-to-water heat pump. Okay. How about here? We're going to get to this side later.
Okay. Do-it-yourselfer project?
No.
So I take it the rebates are not for a do-it-yourselfer.
Here's the biggest thing. It's an EPA certification that needs to be had in order for anybody to buy these.
Solar's,
means your
solar's become
contract.
that way too.
His program, that when he's saying go to a that they got a list of contractors, they've done a couple of things. They've actually have some pretty good rules what the contractor has to follow. One of them is to be EPA certified. The other one has to prove that you went to 8 hours of training on a particular product. So his contractor list is not one that he picked out of that Energy Efficient picked out of the phone book. It's actually ones that people have actually taken the time and gone to a training.
Yeah, well, because refrigerant is a pretty toxic substance. You know, they don't want people who aren't trained to deal with it. So that's why, we want to have a contractor do it. Any questions, or I'm sorry, I ignored you guys, about the plant shirt?
I had a question about the heat pump water heaters, and just curious about when they're more and less efficient based on the space they're in. I have one in my basement, and it has hybrid and regular mode as well as the heat pump mode.
Yeah, go ahead. So she's talking about a heat pump water heater and a hybrid mode, which means that it will revert to being an electric water heater if it can't meet the load, if the heat pump cannot meet the load. They work really good if you have like the classic utility room setup, where you've got the hot air furnace right here, and it's a utility room that gets very warm. They're really good at taking the excess heat out of that room and putting it in the hot water. If it's all by itself in a basement, like here's the thing we run into with new homes. Very tight, very energy efficient homes, no traditional heating system. They want to just heat with a heat pump, maybe they got a wood stove backup. But there's no heat source in the basement. It's just cold down there. And the heat pump water heater runs and runs and runs and makes it colder and colder and colder. And they're like, oh, it's 50 degrees in my basement. And I super insulated it. It should be warmer than that. Well, we're using all the heat that's in there to make hot water. So they work best if there's a heat source that they can rob.
And if there is a heat source, but it's a large space, then what kind of
That's
temperature?
fine. That's totally fine. Probably isn't going to affect the temperature
Right,
more than a degree or two.
right, okay.
Yeah. You had a question here, sir?
Yeah, is the air to water heat pump as efficient as air to air?
Pretty much, yeah. Except where you have, we talked about the case where you have ancillary energy use in the distribution system. That's going to factor in as well. So you look at the listed COPs and the listed performance of them, and it's very close. It's right in there. Any more questions you have, sir?
Do you have to recharge the line set ever?
No, you shouldn't have to. You shouldn't have to. If it's had a proper charge, it's installed properly, no.
Okay.
The only problems we see is when they really weren't installed right. You have one here?
So if you have a ground source heat pump, are there people that, well, first of all, it was $20,000 plus. I'm assuming there are people that have them though.
Sure.
So do they get rid of is that their sole heating source since the ground doesn't fluctuate in temperature?
Yeah, they will tend to be the heating source. So you don't necessarily need a backup because the ground is a more stable temperature than the air is. And it's distributed, right? So we don't have that cold wing of the house that we can't do anything with without running that zone on the boiler. So they will tend to be a whole house system without backup. In the back, sir?
On the subject of the ground source, what are you running through the pipes, and could you drive equipment over them? When you drive equipment over and you drive the frost down?
So the pipes would be like polyethylene, like black polyethylene tubing, pretty tough stuff. And they're, a good 8 feet under the ground, 6 feet under the ground. So it's not really that big of a deal to run equipment over them. I don't know how soft the soil is. I don't know what equipment we're talking about. But in general, they're pretty far down there and pretty burly and isn't really a big problem.
And what do you run through it?
Water or glycol.
Just like all.
You can use an open type well type, but there's so many different types of ground source heat pumps. You can use an open well to where you're using your drinking water as part of your water, but you got to be careful of that. But
I showed you that vertical column one.
have essentially underneath the driveway?
Yep.
Under a driveway, probably, but the soil's gonna get colder there because it's plowed.
Driven on and the process going deeper.
That's why I asked.
So, on a unit like this, I assume you could have one outdoor unit and several inside?
Yep.
Could be how that,
That would be the multi-split configuration, one outdoor unit and multiple indoor units.
and then for a retrofit, what does the plumbing look like that goes between those things that you're trying to run into your walls or ceilings or whatever?
Well,
Is that-
it's a line, it's a refrigerant line, it goes into some sort of distribution box. So the line set from the outdoor unit,
Here's your line set.
Can you bring it right over in the front? That would be,
Absolutely, you can do anything you want.
so the line set would go from the outdoor unit to a distribution box, and then there would be line sets that go from the distribution box to the different indoor heads.
So this is a typical line set, because it's a single-headed unit. So this is a typical line set that you're gonna run and snake it through the walls into the indoor unit to outdoors. If your unit is over where those jackets are, and the only place you can come out of the wall is right here, then this is gonna be exposed to the outside. But, with that being said, they do make a covering very similar to this that can actually hide the line set. This comes in white, gray, brown. There's one other color, white, gray, brown, and I can't think of it.
Assuming you can paint it.
You can paint it. And, white, gray, brown, ivory. So you can paint it if you wanted to. But this is a typical installation of what you're gonna have outside. You're gonna have a condensing unit that looks very similar to this, a little bit bigger in size, but this obviously is a small one for the display, and once upon a time it was working, but there is issues with it. I apologize, because I wanted to show you something, which I'll just talk about it. You're gonna have a disconnect on the wall, that's needed by code, and then you're gonna need something of this nature if you wanna hide the refrigeration lines. Now, if the lines come out low, then you don't really care. There's also, if you're building a really tight house, there's special boots that can come out and actually squeeze right around the refrigeration pipe, so that if the house is being air tested, the holes through the holes through the outside wall actually are sealed, and it makes a better seal for the house. There's those also. So there's different ways how a contractor can actually install this in your house, depending on what you want to look at.
So, I actually want to introduce Paul Blanchard.
Yes, be a good time to share. I'm here. Anybody who wants to talk after?
Thanks so much, Matt. From FW Web, so he's gonna go through, I think, a presentation and everything.
Yeah, so I was asked to come and, yes,
Do the exterior units need to be located at ground level?
no, they need to be elevated up 18 inches.
Can they be higher than that?
Absolutely. And I'll tell you why here in a minute. So, I was asked to come and do this little thing here and talk a little bit about product and stuff. But this is not a sales pitch. I'm not going to sit here and talk about the one particular product that we carry. Steve showed a lot of things on the different kind of products, from the Fujitsu's, the Mitsubishi's, the Dakins, the Carriers, the Hires. They're all great products. I'm just going to touch bases on what we have, but again, it's not a sales pitch. I'm going to try to keep it as general as I can. Unfortunately, Steve took a lot of my thunder because he talked a lot about what I was going to talk about, but that's okay. Yes, sir.
So, what's your distance from your compressor to where it goes into the wall? How does that, what's the max you need?
Great question. So here's the max, and the max doesn't matter if it's just our product or not. The max on a small unit like this one right here is 65 feet
Outside,
total.
total.
So if I have 30 feet inside, 30 feet outside, I'm good. If I have 30 feet inside, 45 feet outside,
Okay.
If I'm a bigger unit, so from 9 to 12,000, I'm 65 feet. And the reason is because we use a rotary compressor in those small units. I use a different type of rotary compressor in the bigger units. Now I can go 95 feet.
you say 9 to 12,000, you mean BTUs?
BTUs, yep. Yep, 9,000 BTUs, 12,000 BTUs, yes.
Is there a minimum that
No.
you need?
Well, yes, 15 feet. I'm sorry, 10 feet. So I cannot put a unit here, outside unit here, because I need the footage a little bit, and you're not gonna like it, it won't work very well. So, Steve made a lot of great, Matt, sorry. I don't know why I called you Steve, but sorry. Matt made a lot of great points. Like I said, he took my thunder away on a lot of stuff. But the one thing, and I know I just talked about it, is getting together with not his contractors, but the contractor list that he has. Because these guys have gone to school, these guys have at least done 8 hours of training on a particular product. All our products are about the same. Electronics are different. How it works is a little bit different, but they all install the same, whether it's mine or anybody else's. So if these guys have gone to the training, they know how to set them up. Trust me, I do regional tech support for webs for the state of Vermont, and I've been on a lot of jobs, and there's a lot of jobs that haven't been put in quite right. And it's because somebody decides that, hey, this mini split business is a great business, and I can make a lot of money doing it. Because the pricing that Matt said was pretty darn close to what contractors are getting. And they're making okay money, so people are saying, let's jump on this bandwagon. Well, if they're not trained properly, you guys are the ones that are going to be suffering. So his alliance with the contractors, that's really good, because that means they've gone to training. So that's a good thing. Because these things are pretty sophisticated. If I took that cover off that unit right there, there's nothing but electronic boards in here. And if you don't know how to set these up properly, you're going to be SOL. Matt made a little, probably shouldn't tell you this, but I will. Matt made a little comment about the styrofoam and the mouse getting up in there and making the nest into the head. The unfortunate part is that, and again, it doesn't matter whose brand it is, these things are nice and warm in the wintertime, because we have a compressor that runs, and the compressor gives us a little bit of heat and stuff. And we all know what happens when a compressor, or we have a warm place. There's little things that kind of like to get up in there and crawl and chew wires and stuff like that. That's probably one of the biggest nuisance of these things. Is it really, really bad? No, but it does happen. So. All right, so I'm just going to talk a little bit. Again, this is not a sales pitch for Daikin. They didn't ask me to come in here. They asked me to come show a product. I'm not going to make it into a sales pitch. I just want to make some general things. So we talk about heat pumps, this technology. I've been in the trade since 1975. Heat pumps were really big back then. Everybody was putting in heat pumps and taking the place of electric heat because of the efficiencies of what they were. But heat pumps were kind of put in wrong. And these guys here, over the lake, over the pond, actually developed a product that really does heat the house. Conventional heat pumps had a little bit of issues. You can see that it hasn't been, it's not as if this is a new fad. This just came out 5 years ago. This particular company, Daikin, that we represent, has been in the business since 1982. You can see where they started playing around with heat pumps. And they just started getting better and better. Now, granted, a lot of this technology was over in Japan, and it came over here. I've been in webs for 16 years. We've had this particular brand for 16 years. And I've seen this brand start off here and come all the way up here. So it is a technology that has been around, and it is a technology that works. One of the things that makes this technology so well is that this thing has what they call an inverter compressor. I won't get into the technical part of it, but basically, if you can picture when you get into your car and you're going on the interstate, as you come up the ramp, you put your foot to the gas, and the car goes faster and faster. This thing does very similar. I invert my technology, so as the load changes in my space, the hotter I get in my space, or if I'm using it for air conditioning, as I'm cooling down, my compressor outside is going to go up and down. That's where your savings is. That's where the real efficient savings is. I will tell you that anything from 9,000 BTUs to 24,000 BTUs are amps. Service that you need outside is a 20 amp 2-pole breaker. So that's a 20 amp 220 line. You can feed a 9,000 BTU all the way up to a 24,000 BTU. Pretty small service, really, for what you're getting. One thing that it does, obviously, because I'm a little bit inverted technology, there's a bunch of features here, and I'm not going to read each one of them. We're not going to go through each one of them. But when these compressors start, when these things run, they're really, really, I wish I could get this one running. Sorry, this thing has gone to so many shows. I just plugged it in. I think I blew the breaker because something is wrong with it. Totally apologize. It's kind of embarrassing because I really want to show you this guy. But these things are really quiet. You can barely hear these things run outside. So if you put them underneath the bedroom window, you got to be careful, but they are fairly quiet. Your neighbor's not going to complain that it's running if you get neighbors that close. Again, because it's inverted, we're not going to have the sudden stops and sudden starts all the time. And if anybody here has a window air conditioner, whether it's a window air conditioner or a big air conditioner, and the air conditioner comes on, you can tell because the lights start dimming in the house. We won't have that issue here. Again, I'm not going to go through all this because he's actually really kind of plugged away at it pretty good. The one thing that all these brands have, which makes it nice for the contractor, but it also makes it nice for you because you can learn fairly easy. You can actually kind of find out what's wrong with this thing. Why isn't it running? This thing has 18,000 million codes, and it'll tell you exactly why it's not running. From a leak, to being overcharged, to a fan not working, to a filter being dirty. Again, there's a lot of varieties of what you want to do and what all the companies have to offer. The wall mount is the most common unit that most people will put in. Now, one thing that Matt mentioned, he made a great point about the wall mount, is that the wall mount will heat and cool one particular space. If you have an open floor plan to where you have a great big living room and a great big kitchen, one wall mount unit will probably do the job and take care of it. Will it do the bedroom down the hall? No. It's still going to be a little bit cool in there. But it will do that one space. And that, after all, that is a space that we probably spend the most of our time in. But we also offer a little slim duct unit. Again, they have slim duct unit. To where you can build a little bit of soffit, and I can put a little bit of ductwork off this. And I can maybe go and feed another room on the other side. Or if I don't want to see that ugly wall unit, I'll put it in here, make a soffit, and just put a grill here and have it come out. Especially if you're doing new construction, you can do this. The warranties he was mentioning are great. This one here is a 12-year parts warranty. Anything goes wrong with this piece of equipment, 12 years, parts are covered. Labor isn't, but the parts are. They all come with a wireless remote. So you can see a wireless remote. Looks very similar to your TV remote. Has a lot of buttons on it, a lot of features with these things. Our particular, and again, I'm not going to get into all the features, but he mentioned one of them that when you come into the room, you can actually have the unit come on. So when you leave the room, or when you go to work, and they don't see any movement in the room, it'll actually change the temperature automatically. In the cooling season, it raises it. In the heating season, it lowers it. When you come into the room, she comes on. That remote can do all that. You can have a timer if you want. So you can have it come on at a certain time. There's what they call a powerful mode. So you come in and it's really cold in the house. You can hit this powerful mode. It's going to make this thing go 100% for about 30 minutes, then shut off. So there's a lot of good things. The remote is not the temperature sensor. The sensor is actually in the head itself. So you can take that remote and lose it, the dog can eat it, kids can play with it, they can't do anything with it. Again, we have different type models, and I'm not going to go through them all here. We have floor units, very similar to what the picture that he had, that our competition has. They all, floor unit to floor unit. You know, they look a little bit different. What's that?
What's the second stuff that I showed before you?
Was it? Oh, okay. No wonder. Okay, see, you showed good stuff. We also have a ceiling cassette. So now, if you're doing a house, or if you get up in the attic space, and you want to put that cassette in the middle of the room, again, if we have an open floor plan, that is possible. And we have our slim duct unit. Again, these are just more variations. This happens to be our 3-port unit. He talked about this a little bit. So now I can have 3 heads on one condenser, and I can have 2 heads on one condenser depending on what size unit I want. So let's say I do the living room. And now I want one in the bedroom, maybe a master bedroom, and one maybe in my child's room. I can do that with 1 unit. Obviously the unit's a little bit bigger. The other thing you gotta remember is that because I have 3 units, I got 3 different refrigeration lines coming out. So now I have more lines coming out of the house. I am still on a 2-pole 20-amp breaker though. And the power for the head comes from the outdoor unit. So when the service guy or the guy installs it, he brings refrigeration lines, he also brings a cord with him. And that power from any one of these units comes from outdoors. If so be it, and you're doing a larger home. Yes?
So when you run your lines, are you running them interior or exterior if you have a multi-unit?
Sure. Not being a smart ass, okay? It's up to you. If you can't go outside with it, you can run it interior. If you want to go down to the basement.
Up to your attic, for
sure.
instance.
Absolutely. Absolutely. The only thing I'm going to caution you is that if you go up in the attic, make sure that that contractor has those lines really well insulated and nothing can get to them. Because if not, in the summertime, if you're utilizing it for air conditioning, it's gonna leak down through your ceiling. Now, with that being said, I run it up through the attic and I want to use this as an air conditioner because what the heck, I'm buying this as a heat pump, might as well use this as an air conditioner, right? Well, one thing all air conditioners have, and I don't know if you noticed it or not, but even if you got a window air conditioner, there's water that comes out of them because they condense. So now I put this guy up on the wall, and I decide to bring my refrigeration lines up in the attic. That's all well and good. That works, and it'll work forever that way. But I got to do something with the condensate because it's going to condense. So somewheres I got to get rid of that condensate. They make little pumps that go in here that'll pump up about 6 feet high, and then you have to gravitate down to it. So if you're 6 feet within the ceiling, confound your ceiling, and you can get up that attic space, as long as you have a pitch down to a drain, that's fine. So that's just something to keep in mind. We do need condensate. We do need condensate pumps for each and one of these. No matter if it's that head right there, that wall head, or that ceiling cassette. If you get into a larger house and you want to build a house, and you want to do some duct work, and you really want to go this way, we actually offer fan coils. They're a little bit bigger capacity. The one thing I will tell you is that these particular fan coils do not fall under Efficiency Vermont's rebate program. So that $600 or $800 that he's mentioning, that would not fall underneath it. But if you really don't want to use any fossil fuels, you could do this. A few houses in Stowe are like this that I've done. And there's a few other places that are using a lot of this as supplement, mostly this most of the time. Again, I'm not going to go through all these, but again, it's just some of the product that is offered, just to give you a real rough idea of what is out there. Matt talked a little bit about service. Highly recommend have a service, have somebody come in and look at it. If anything, just look at the condenser to make sure there's no varmints that got inside there. I had a board that was brought back to me, 2 boards that were brought back to me that were pretty interesting. One of them, I went on myself, it was a buddy of mine, so I went and took a look at it, and his unit wasn't working outside. So I started playing around, and I said, you know what, you got a bad board. So I have to replace the board. The board's under warranty, no big deal. Labor was free, besides the beer I drank, so I guess it was good. So I took the board and took it out, but I also, when I was taking the board out, I'm thinking to myself, these don't fail too often. There's an issue. Could not see anything physically when you first took it apart. I took it all out, took the board out, set the board down, put the new board in, and my head's still saying, something made that board go. Why? I'm a great big fan of why. I teach a bunch of classes for the company, and one of the things I always tell the technicians in front of me is because I'm like a 3-year-old kid. I always say, why? You guys need to learn that. So I kept saying to myself, why did that board go? I turned it upside down. There was probably a garter snake about yay big that got inside the unit, crawled up in between the boards, and kind of laid there to get warm, although he didn't realize that he was toast and he was never coming back out. I had another board brought to me, just give you an example, another board brought to me last fall that probably had over, I didn't count them because I wasn't that bored, but I bet you about 150 ladybugs on the board. So, maintenance is good. Somebody could have probably caught that and taken care of it. The least they would do is actually, because they could wash the coil, make sure the coil's clean outside. Make sure your coils are clean inside. There is a chemical, a spray that you can actually spray the coil inside and disinfect it. Because after all, when we're air conditioning, we have condensing, and has a tendency to give us, at times, a little bit of a musty smell. So they could actually go in there and do that. The one thing that our company has is we have an air filter that needs to be taken out and regenerated. And it's probably something fairly simple. Now, if you're fairly savvy and you know how to do stuff like that, you guys can do it on your own. But the air filter itself has to be taken out and put in the sunlight for about 5 hours. And once you do that, you're regenerating that particular filter, and it's supposed to be filter out a bunch of yuck stuff that's in the air and all that. And so that's at least that needs to get done. Other than that, that filter is not doing you any good. I'm not going to pound this.
Question on filters,
Yeah.
just before you move on. The filters, you don't have to buy a new one.
No.
You take care of it. You clean it.
Correct.
You do your business. Is that with all the models, or?
That's all the models.
Okay.
So none of our
So maintenance is.
correct, and none of our
straightforward.
and I believe my competition's the same way. Those are all washable filters. It's not a special filter where you can't buy at Overshaw Hardware. You can't buy these at Overshaw Hardware, but it's not a filter that you need to buy at Overshaw Hardware, because if you're really gentle and wash it with a little bit of nice water. Now, if you bring it out in the garage and take the hose to it and put the hose right to it, then you might put a hole in it. But
But
again,
they're made to be
correct.
clean.
Common sense stuff, you can clean them, not a problem.
Well, there was another question in the back.
Yeah, sorry.
I was wondering, if a mouse or a garter snake or something is the problem, is it gonna stop functioning? Will it just lose efficiency? Like, when do you know you have an issue there?
It won't work.
Just seize up.
What?
What will the diagnostic code say?
Great question. Great question. It's going to say the cat didn't do the job. No, great question. So what's going to happen is you're going to go through the diagnosis, and everybody can do this because everybody has a handheld. So all you do on ours, I can't talk about our competition, but I would have to say they're the same. But on ours, you hold the button down, and then you go through to about 12 different codes. And what it's going to give you, it's going to say there's a communication problem, because it doesn't know. So now you've got to start looking. And communication is either a broken wire or we got a bad board or something. That's usually
So I
what it's
wouldn't
done.
start looking, I'd call you.
Well, you wouldn't call me, but you
Yeah.
call their service guy. Yes.
Yeah.
Correct, Mundo. Okay, I'm not going to go through this because he's already done a great job with this, the COPs and the efficiencies and all that. The only thing I'm going to caution you if you're really looking to do something like this, get the highest efficient unit that you can get. Now, whether it's ours or whether it's our competition, I'd like to think that we're within all in the same boat of each other. Yes?
Does efficiency change at all if a unit's located on the south side of the house versus the north side?
No. No.
Even for air conditioning
No.
on the south side?
And what about if your lines, if you have a multi-unit, are interior or exterior? I'm presuming if they're exterior, they're gonna be insulated.
Both interior and exterior have to be insulated no matter what. No matter what. Lines, now, you asked what the lines were, and I told you what the lines were for individuals. If you have a multi-port unit, a 2 and a 3-port, you have an equivalent up to 230 feet. So that means I can have one unit at 30 feet away, I can have one unit at 60, so that's 90. And now I can have another unit 100 feet away, and I'm still within that 230 feet. Yes?
Do interior lines need to be left accessible?
No?
Can they be within an insulated wall?
Yes?
And then the condensation you're talking about, that's only if the line is running vertically up?
You need to get rid of condensation no matter what.
Air conditioning.
Air conditioning, no matter what, you got to get rid of condensation.
And that comes out of the head of the interior?
That comes out of the head.
So as long as the line is running down?
Correct.
Okay.
So are you saying that the refrigerator lines that you're running from outside to inside, those are going to condensate?
No, no. When you're so in an let's talk air conditioning real quick. Air conditioning mode is my indoor coil gets really cold. Because that's how I'm not being a smart ass, okay? But that's how I cool my space. As my warm air comes across and hits my air conditioner, that warm air is going to condense on a surface, very similar to ice does on a glass of water when you put it on the counter. You start keeping it there long enough, the outside of that glass is going to become wet. I'm the same way. I have warm air coming across, I hit that coil, I'm condensing on top of my coil, and now I'm running down into a pan. I have to get rid of that. I have to either throw it outside, throw it in the basement, throw it to a drain somewhere, so I got to get rid of it. Because other than that, you're not going to like me because you're going to call me and saying there's nice streaks coming down my wall.
But your insulated pipes aren't going to sweat?
No. We came out with a new type air, so if anybody here would really like some fancy round curve units, we actually have those, and we come in silver and we come in white. Again, these are my little round units. The ceiling cassette has changed a little bit. Again, that can be put in a suspended ceiling or it can be put in a sheetrock ceiling. Not a problem. I'm going to give you a really quick scenario here. If we were to look at, we'll make it easy and go over to my last tier unit right here. So 18,000 BTU units, and if you can follow that 13 below, at 18,000 BTUs, that LV unit is going to put out 5,688 BTUs. So Matt was saying, as the colder we get outside, our BTU output is less. If you're doing a room, and I need 10,000 BTUs to heat this room, and you say, I'm going to go bigger is better, so I'm going to buy a 15,000 BTU unit, because I need 10. When it gets 13 below, that unit's only going to put out 5,688. Now, we have a cold climate unit, which means it actually goes a little bit better, and you can see that same unit, that same 15,000 is going to put out 11,109. Cost difference is within pennies of each other. So if you're going to do this, tell your contractor you want to make sure you get the cold climate unit. Because we do offer 2 units. Both units have the rebate. One gets better than the other.
Why would you sell both? Why not simply do the cold climate in this area?
Some people don't want that. Hard to believe. I'm not. I probably sell more LV units than I do the cold climate units. Yeah, go ahead.
So, if you were to get the bigger unit,
Yeah.
is that like a bigger boiler? Is that less efficient when you don't use it all?
No. Well, great question. Tremendous question. So some people will say bigger is not better, right? In this instance, it's a little bit different because technology has changed so much. Because of my inverted capacity. So I have a car that has a 357 Chevy. Okay, well, it's going to use as much energy depending on how much gas I put in. Now this is kind of a real bad analysis, but if I have a Volkswagen, again, I'm in the same, depending on how much energy I'm putting into it, it's going to be depending on how much gas it sucks. This thing does the same thing, it's inverted. So if I'm bigger, and I don't need that much heat, guess what happens to me? I'm like a modulating boiler. I start modulating down, and I put out less BTUs. So when I do that, I'm not using up that energy. It's not being wasted.
How do they, I assume they, when it's in the heating mode, the condensing unit needs to defrost occasionally?
Great question.
And how do they do that? Elements or?
Great question. That's good. I'm glad you asked that question. If we were getting into technical stuff, that's a great question. So basically, what happens in the heat pump mode is we turn an air conditioner into a heat pump. So in an air conditioning mode, I throw nice cold air into my house, and I throw warm air outdoors. In the heat pump mode, I do just the opposite. I throw the warm air in the house, cold air outdoors. Well, again, because we're married to the laws of physics, we're outside. I got a nice cold, fairly cold coil, but I still have moisture outside even when it's 20 degrees outside. So that moisture is going to come across my coil. My coil is going to be colder than the ambient air, and what's going to happen is I'm going to start getting crystals. So if you go outside a unit, you're going to find an air conditioning unit full of crystals, and it has to defrost. So what it does, it actually turns around into an air conditioner again. Now what it does, it shuts the fan off inside, so you're not getting any cold air being blown in. You're shutting this guy off, you flip the switch, you don't, they do. A switch gets flipped, we make that into an air conditioner. Instead of this warm air heating the house, now I got warm air outside, and I'm getting rid of all my frost. Now,
Is that part of a cycle, you mean?
yes, it's part of a cycle.
A reverse cycle.
What this thing does is it looks at temperature, and it looks at all this thing. Because this thing works everything on temperature sensors, it looks at a bunch of temperature sensors, says, okay, I need to defrost. I'm going to go into an air conditioning mode. Now, Matt made a great point. He talked about a particular house that they did, and people turned the heat down to 65 degrees. I have a house down in the southern part of the state, not me personally, that has an issue. And the issue is that the people were going outside and seeing this thing full of ice. It was all frosted up. So two things that happened in that house. First of all, the unit was put in, and it's drastically oversized because it's such a small room. When then they went in and they spray foamed the room and stuff. But the biggest thing that happened is that the homeowner decided that upstairs, I want to keep that room at 62 degrees. Okay, no big deal. So you keep that room at 62 degrees. The unit doesn't run long enough, and what happens is the unit needs to go into defrost, but guess what? The thermostat's satisfied, and it don't go into defrost. Then when it goes into defrost, the thermostat gets satisfied, and we don't need heat anymore, the unit shuts off. I never defrost outside. The unit didn't ever stop running. The unit kept running and running. Not a problem. Homeowner didn't like to see the frost on the unit.
So Paul, I got a question for you.
Yeah.
What happens when you have ice on your coil
Yeah.
and you melt it?
Yeah.
In the winter in Vermont, when you melt ice, it turns into water.
Yeah.
And then what happens to that water?
Perfect. I'll get to that in 2 seconds. So this is our colder climate unit. Again, all these, don't pay attention to that one on the left-hand side, or don't pay attention to the bottom right here. Again, I'm not trying to bastardize any of my competition. But the up-top scale is actually a real great scale that you can get from any contractor. And basically what that's going to do is going to tell you what the temperature, how much BTUs a particular unit is going to put out at 47 degrees outside all the way down to 4 below. Now Matt made a great comment about these things not shutting off. Ours are the same way. Ours are rated down to 13 below. But that doesn't mean at 13 below I'm going to shut off. All it means is that we stop rating it, or they can stop rating it at 13 below. At 13 below, these guys will still run. These guys are in Canada. Again, our competition, I'm sure, is too. These guys are in Canada, where the temperature gets a heck of a lot colder than around here, and there hasn't been any issues. The thing just keeps running and running and running. Now, what it's going to do, it's going to keep reducing your BTUs. So now that chart I showed you before, one of them that was given 11,000 BTUs at 13 below. Now, if I get down to 20 below that 11,000, it probably is going to be about the 10,000, 9,000. So again, caution if you're trying to heat a space. Make sure that the way to pick an air conditioner is this way. Have somebody tell you how many BTUs it's going to, or unless you want to do it yourself, how many BTUs are going to for me to heat the space. Okay, so it's going to take 12,000 BTUs. Make sure you pick a unit that 13 below is going to give you 12,000 BTUs. You're going to be drastically oversized for the cooling. But because the compressor does is inverted, you don't care. It's not a conventional system. If I'm drastically oversized, I'm going to turn my cooling on, and as I start getting colder, my compressor is going to go slower. The energy is going to be even less. So you want to match your heating, not your cooling. And again, there's a good picture of that remote. It has 18,000 million functions, it has more functions. I tell you, that remote sometimes is the biggest pain. Because I go to a contractor to a homeowner, and it doesn't work. It's a pain in the butt. You got way too many buttons on there. There's one button on there that says quiet mode, outdoor quiet mode. I just went to one last week down to Rutland. Lady says it's noisy. She has a 2-head unit. It's noisy. I can hear it at night. I can hear the refrigeration going through the unit. And what I did is I put it on quiet mode, and I can still hear it run. Well, obviously nobody explained to her what quiet mode meant. So the quiet mode means nothing to do with the inside. The fan's going to continue to run at whatever speed you decide to put it on. But what the quiet mode does is it reduces the capacity of the unit outside because it slows the compressor down and it slows the fan speed down so that it's not so noisy. It was really made for summertime if you had your window open or it was underneath a window or something like that. So when she put it in quiet mode, I reduced the capacity of my unit, and what she was hearing was the refrigerant going through the unit. So I told her, I said, could you do me a little favor? How about if you don't use quiet mode? And then I explained to her what quiet mode really was, and she was okay with it. Now, knock on wood, it's been over a week and I haven't heard from her, so I'm assuming it's going to work. Dear daughter, she ripped it out. One of my favorite thermostats is this guy. So any one of the products I just showed can have one of these thermostats. It's an NV thermostat. Again, the main reason why, one of the great reasons I brought this is because I wanted to show this. And here's what it does. This is a Wi-Fi thermostat. So you have Wi-Fi in your house, you can do what you want. You want to go away for a couple days and turn the heat up and down, and when you come home, easy. Get on your phone, done. The other good part about this right here is that, let's say you're picking out a heat pump to heat a space for maybe 75% of the time. Okay, so for 75% of the time I have existing baseboard. I'm going to bring this in. For 75% of the time, I'm going to heat my space. I think Matt had a great example of it. I think he showed it was like 80%. So 75% of the time, I want to use this guy to heat my space. And I'm going to put this guy on the wall, my thermostat. You know what's really nice about this? Is that you can tell this thermostat a lot of things. And it's going to tell you a lot of things. You can tell this thermostat that at a certain temperature outside, I want you to shut off, and I want the baseboard to run. You can tell that thermostat that, hey, if I'm not keeping up with this space because it's too cold outside, turn my baseboard on too. You can tell this thermostat to operate them both together or not, or you can tell this thermostat to do whatever you want, and it'll pretty much do it. The nice thing about it is this thing will give you alerts. So you leave your house for a couple days, it's going to call you and say, hey boys, I got a problem here. We just died. Okay, so it'll give you that kind of alert. It'll tell you when it's time to change filters. It'll tell you if there's something wrong with the unit. You're going to see an error thing. It's going to tell you exactly what the code is. So instead of you sitting there with my remote, it's going to tell you what the code is. Pretty pricey. When I say pretty pricey, they're in the $200 range. But it's a great thermostat, and it does a lot for you. I really like the thermostat. There's a lot of jobs that are being sold. And I will tell you that there are jobs. If you go through Winooski, there's a great big 4-story building going up. That's all that's going in. There's where the old Dairy Queen used to be on one of the roads in Burlington, if you don't know where that is. That's a 4-story building. That's all they have in there is a Daikin with a small piece of 8-foot baseboard radiation in case this thing fails. And that's heating apartments over there. And I could name 3 or 4 other projects that's all is being heated is by heat pumps.
When you said that 8-foot radiation in case that thing fails, you mean if it stops?
Yeah.
Or if it's not able to meet the capacity?
Or both.
Yeah, okay.
Correct. Because let's face it, this is moving parts. I mean, no different in your boiler or your furnace. There's gonna come a time, if I sat here and told you that this thing's gonna last forever, I'd be lying to you. There's gonna come a time where it's gonna fail. You know, it could be as simple as a mouse getting inside it. It could be something, a board gone. And now we have to get a board. I mean, we have most of the parts that anybody would need, but still, the guy's not gonna, the one thing is, the little bit of difference is an oil burner man will come in the middle of the night and probably have a fuel oil pump, or have an electrode, or have a transformer on his truck. What he's not gonna have is probably a board for this guy. And especially if he's a multi-brand guy, and he puts in this, he puts in Fujitsu's, he puts in Mitsubishi's, he sure as heck ain't gonna have a $200, $300, $400 board sitting in his truck doing nothing. And I don't blame him.
When the units do fail,
Yeah.
is it just as simple as replacing the interior and exterior units themselves so the lines can remain properly?
Correct.
And wiring?
But, I guess I took the little slide out. I'm going to answer your question here in a minute. Correct, but I've probably only replaced maybe a total of 5 units in a year. I don't know how many Rutland did. Between Rutland and my store in Williston, there's just over $3 million worth that were sold in the state of Vermont last year. That's a lot of units. And for us to have that little callback brought back is pretty phenomenal.
I'm saying after 15, 20 years.
Haven't had any come back that long, to be honest. We haven't seen that, but it's no bullshit. We haven't seen that only because these things only started getting popular maybe 4 or 5 years ago. So for me to sit here and say, no, they don't come back, I'd be lying to all of you. Because it's still early. And I'm sure my competition's the same way. I would think. Matt asked a question. So when I go into defrost, what happens to the water because I melt the ice on that? He showed you some pictures of stands. One of them was a beautiful stand on the ground. The thing has to be elevated 18 inches high. The reason is exactly for what he said. When we go into a defrost, that water has to go somewhere. If this unit is sitting on the ground and that water hits the ground, what's going to happen? We're going to freeze. Even though there's 18 million holes in the base of this, we're going to freeze. Eventually we're going to freeze so much that I've seen the fan blade in here full of ice because the ice has come all the way up inside the unit and the fan blade can't turn. What's going to happen is that your unit's going to go off and it's going to tell you that there's a problem outside. You go outside, you look, sure enough, you have ice in there. Contractor or somebody did not elevate it up. That's the reason. They have to be elevated. If you're going to use them for heat, they have to be elevated a minimum of 18 inches off the ground. Either you hang it on the wall, you put a stand underneath it, somehow, some way. Okay, I'm going to put them on my roof. Still has to be lifted up 18 inches because the roof is no different than the ground. I thought I had a picture of that, but obviously I probably took it out. I can't find it, I don't see it. All I have in a real nutshell. Again, just if you're going to do this, look for the most efficient. Just remember that these do not give out the full BTUs at below 0 because you're still married to the law of physics. At 13 below, they give out about 65% of what their total capacity is. If you're going to buy one, size it for the room that you're buying it for, heat-wise. If it's oversized cooling-wise, you don't care because of the inverted technology. It will adapt. It will adjust itself. You are not wasting energy by doing that. You are not making your your electric bill go up any higher. My last thing is, and you guys probably have already thought about this, is We just gotta remember a BTU is a BTU is a BTU. So if I need X amount of BTUs to heat my house, I need X amount of BTUs. It's up to you and how you want to do it. If you want to pay money for fuel oil, if you want to pay money for electric bill. Just remember, if you put one of these in, your electric bill is going to go up. So if it goes up, don't call your contractor or me saying, hey, my power bill's gone up, because I'm just going to turn around and say to you, what did your fuel bill do? Did it go down? Well, I don't know, I didn't look at that. He's not here as often, but my light bill still went up.
Refer back to the chart of the 3 to 1.
Correct. That's all I have. Thank you.
Thanks again.
Does anybody here have one?
That's actually my next question is, yes.
Yeah, I
does
have a
anybody
couple of
any
questions.
experience?
One is there a contractor here? And does anybody have one of these units?
I do.
Okay. I have two. I have a floor unit and a wall unit. The only time it gets used for heat is in my bedroom. The living room's covered up, because I use a wood stove. The one in the bedroom gets turned on a fair amount when it's cold in the morning. My wife likes to turn it up. When she goes in her shower, she wants to come out and wants the bedroom warm. She turns it up. Most of you have seen me, know me. If you got a question I can answer, I'll answer it.
So I have a question.
Sure.
How does it perform? When it gets really cold and stuff, what's it do?
As I said, I don't use it a lot in the winter. The bed, we will turn it up in the bedroom a little bit. My bedroom is probably 13 by 13 and it'll heat the thing. I've not turned it up when it's below zero. The big thing I do want to tell people, if you've got baseboard hot water heat or hot water heat, when it's below zero, let that system do its job. You know, those pipes are 6 inches from being outdoors. You know, when you go up through the floor, you got a 2x6 wall plus another 1.5 inches of space in that ceiling if your sheetrock below and your flooring's above. That pipe's that far from being outdoors. Let your heating system do its job. I've been to a house this winter. You know, the same with a wood stove, not just these units, but a wood stove, a pellet stove for backup. And when it's below zero, turn those things off and let your heating system do its job if you have hot water. You know, those pipes are that. I've been to a house this winter that's totally busted because somebody had a pellet stove and the thermostat never called for heat and pipes burst.
Yeah, but I saved energy.
Does yours perform? Have you used it in the middle of winter, and how does it do?
Yeah, I have a Renai heater for propane, and that's undersized for my 1,300-foot house. So when we were below zero last year, my house was 50 degrees. You know, we're talking like 20 below. It's 50 degrees, no matter how high I set the Renai. Now it's 60 degrees. I have the Renai going. I have it set at 65, and I have the heat pump. I've never touched it. Talk about set it and forget it. When it was first installed in the summertime, I had it off. We turned it on one day for dehumidifying. Anyway, 68 degrees is what I have it set at, and that just runs all the time. And then the Renai I have set at 60 degrees. My house is 68 degrees wall to wall, and it's probably 65 degrees upstairs or 60, you know, somewhere in the 60s. So even when it was 20 below, my house was 10 degrees warmer than before I got the heat pump.
Good for you.
So I love it.
I think I've been following Matt for years, and one of the things that he said that earlier was the whole set it and forget it approach, which goes against everything every one of us who are still here believes in. We've always been set it back at night. So in your point in the corner over there, using it to warm your bedroom up probably isn't using it as efficiently as you could.
I agree.
So just keep that in mind. And I have one of these units and it works great, but I just set it and I forget it. And I set it, I don't worry about what the temperature is, I worry about what my comfort level is. So I just don't mess with the thermostat, that's for sure.
I've actually turned my propane heater off,
Yeah.
turned it down, but I've never done anything different with that 68 degrees
Yeah.
I have on the heat pump.
Well, the other thing you got to remember too when setting back is that everything goes in setback. So your furniture goes in setback, your carpet goes in setback, the walls go in setback. So if you set everything back at 50 degrees, you're putting everything in back. Now when you're trying to heat it up, you're trying to heat up a whole mat.
That's right.
The thing with the heat pump is, you're not gonna feel the warm air like you are your hot air furnace. Because the warmest that air is gonna be is about $1.20. So on your furnace, depending on how it's sized and who put it in the duct distribution, you could feel anywhere from 130, which is 10 degrees difference, but it's a big difference, or 140. So it's gonna take less time for you to heat up a big space if you're setting it back. If you're using the heat pumps and you wanna set back, it's gonna take you longer to bring that up. And then you're not gonna be happy because you're gonna think that this thing is underperforming.
I would also say that your central heating system might be 80, 100, 150,000 BTUs per hour. And your heat pump might be 12,000 BTUs. Or when it's cold out, it might be able to produce 8,000 BTUs an hour. So there's a huge difference between 150,000 BTUs an hour and 8,000 BTUs an hour. So think about what you're trying to do. You're trying to maintain the temperature in the room. It can do some of that, but it's going to have a really hard time lifting the temperature, not only the air, but all of the surfaces and all of the components the house is made of, all the drywall, all the concrete slabs, all the steel columns, all that stuff, all has to get heated up. So that's a lot of work to do with 10,000 people.
So I have heard from two people in town that have these installed, and their experience without additional heat is when they get down to in the teens below, their house temperature starts to drop, and it can't keep up. So roughly speaking, if you're trying to heat with only this, you can expect it to not perform terribly well at those kinds of temperatures.
House temperature dropping to what?
That's not clear to me. One of the people is Knox Cunnan, who was monitoring his house when it was empty, his net zero home. And I think it was like dropping like a degree. I don't know if it was a degree for a degree outside or what, but it was in the teens below is where it started to drop. And I think he mentioned it,
Well, when it gets like 15 below, he starts to see the temperature drop in the house.
Yeah.
That's where it came from. Yeah, okay.
Right. So, just to share with people what.
You guys were talking about operating them now. I wanted to jump in with one more thing you can do. Like, there's the temperature setting, yes, but there's also a fan speed setting for the indoor unit. And I will often use my fan speed setting for comfort. So, like, if I'm not warm, I might not need to, like, turn the thing up to 75. I can just bump the fan speed up to the next notch higher, and it'll kick out a little bit more heat and make me a little more comfortable. And I supplement with wood, so that when I come home, I make a wood fire, just because I like the wood fire, but I don't turn the temperature down on the heat pump. I leave that set pretty much at around 62. And then I come home at 62, I let the wood stove at 70, and that's how we work that one. It's a pretty nice setup.
How long do you crank the fan up for, like an hour or 10 minutes?
It depends what I'm trying to do. If I'm just trying to take the curse off the room, I'm a little chilly. What is an older house we live in? It's got a view to one side, and somebody put these ginormous windows in it, which that heat pump can't keep up with those windows when it's really cold out. The wood stove is.
Yeah, my house has a lot of windows.
I would like to also say that out here at the end of this table, I put a sign-up sheet, and if you want to know, like, if we're doing more events like this, you can get an email on that. Also, there are some evaluation forms, so whatever you thought of my presentation, just let me know, and I'll change it, because I try to make it better every time I do it. So just, give me some feedback.
And if anybody wants to steal a cup worth of food, go ahead and take any food you can, because that gives me less to pack up.
Any other questions? Thanks.